Welcome to EF5 Advanced Training, Module 2.3 from the University of Oklahoma Hydrometeorology and Remote Sensing Group. My name is Laura. Thank you for joining us for multiple gauges and output grids. The outline of this, if you've already done the precip forcing with NWP and inundation modeling, we will be going over multiple gauges in a basin, cascading calibration, readying the control file. We're then going to go do an example, and then we're going to look at other EF5 features. So far, in all of our training examples, we have been working with one gauge. This has been fine for our purposes and still gives very good estimates, especially if you use the last gauge of the outlet. However, with multiple gauges and observations, the model would be more robust because of the extra verification. So we're going to be using an example from the EF5/CREST Pakistan example. This example has multiple gauges on a single river, so we do something called cascading calibration. What this means is that we start with the observation location most upstream, and we calibrate there first. Then we calibrate the next observation location downstream. And we keep repeating this until all stations have been calibrated. So the study area that we'll be doing is in the Indus River. And we have about 7 stations that we have observations for. Station 1 is Tarbela, and then so on to 7. So since Station 1 is the most upstream, which is Tarbela, we're going to start the calibration procedure at that location. So the important part of this lesson is to learn how to use multiple gauges in EF5. So this is how we can prepare the control text file. What we do is we give each gauge its own gauge block, which includes the longitude, the latitude, and the observations, and the file path to where you can find the observations. To the right, we can see that we have 2 gauges identified. We have the gauge Tarbela, where we have the longitude, the latitude, and the observations path file. Then we have the next gauge, where we have the longitude, the latitude, and the observation file path. Next is where we create our basin block, and then we include all the gauges that we want considered in it. So in this case, we called our basin Indus, and we included 2 gauges into it, the 2 gauges above that we identified. Finally, we need to account for the parameters for each gauge. So how do we prepare the control text file in this case? We need to account for the parameters for each gauge. So what we have to do is we list each gauge we are using under each CREST param set and the KW param set. So like we've done in other examples, we'll have the CREST param set block. We'll put 1 gauge, and then we'll put all 7 or 6 parameters underneath that. However, we're not done when we use multiple gauges. So in the example to the right, we can see in the CREST param set Indus, we have the first gauge on there as Tarbela. We put all the CREST parameters that we have. And then next we have the gauge, and then we put all the parameters on after that. So under each gauge equals to, we include the gauge that we want to put the parameters to, and then we put the calibrated parameters that fit that specific gauge. So this is going to be an example of how we've used calibration. So we've been doing single calibration for this example. What we did is we used the dream calibration to find parameters, and we got a Nash of 0.74, which is a really great Nash score. So we can see that the observations matches with the simulation really well. We were able to get the peaks simulated really well, as well as the timing of the peaks. Next, we use the same exact values for the first upstream gauge as for this one. However, we only get a Nash of 0.44. So in this case, we can use automatic, or we can just use manual calibration to kind of tweak the values a little bit because we know that it shouldn't be too far off. You can also do this by eye and with manual calibration. We can see after the first two peaks that the simulation is kind of overpowering what's actually happening. So you can go back into your manual calibration, look at what kind of affects why we might be getting more runoff, and lower those numbers. So by using that cascading calibration and just tweaking a few of those numbers that led to the runoff being higher, we actually get a Nash value of 0.67. So now that we have good results for our interior gauge Tarbella, because we calibrated for that location first, we can use this cascading calibration instead of using dream calibration, which might take a long time to do. We can just use that dream for the first one, and then just do manual tweaks for the rest of the gauges downstream. So you would repeat this process for as many gauges as you have in a single watershed. The next important part that we wanted to review in this advanced training is how to get output grids in EF5. A great part of EF5 is that it allows the user to output grids directly from the simulation. And we looked at this a little bit in the last module, 2.2 inundation grids. These are completely optional, but are often useful to see the bigger picture of the scientific processes at work. So this is a little bit of how we can use output grids in EF5. So you put a little bit of an example of the different grids that you can visualize and how you would put that in the control file. So for example, if you want to output stream flow into a grid, into an output grid, you would put output grids, output_grids is equal to stream flow. You can also do multiple output grids in one line. So for that, you would put output_grids is equal to inundation, which we just did, and then you would put an and sign, which is a sign that looks like that. It's on the same button as the slash. All you have to do is press shift slash, and then you'll get the upright slash sign. There's also many other grids that you can visualize that I put on this slide. So we're going to show you some of the outputs from the Pakistan example that we just discussed. You can see the snow liquid water equivalent. And so in most places, you may not need this, but in the Himalayas, you have snow on the mountains. And so this is really important to look at because now we can see how that water can melt, how the ice can melt and become water and create some flooding situations. You can look at stream flows so you can see where the highest stream flows are. You can also look at soil moisture. So let's go ahead and create our own output grids. So what you'll do is you'll navigate to your EF5 Advanced, then you'll go into Examples. We're going to try Wing 2 this time, and then we're going to go to Output Grids. So what we will do is the only thing we're going to change is we're going to add output grids is equal to max stream flow, and then we're going to do the straight sign, and then we're going to put precip. So the output file grids will be the max stream flow as well as the precipitation that the area got. All right, I hope you enjoyed the EF5 Advanced training. If you have any questions regarding topics discussed during this training course, please do not hesitate to email the trainers that are on this slide. Additional training information is available at ef5.ou.edu/training. Thank you very much for joining us, and I hope you enjoyed it.